Witness the dramatic teardown of a decommissioned aircraft where forgotten giants meet sparks, steel, and skilled hands. The replacement process of the gas turbine at the Gendorf power plant begins with carefully dismantling the old turbine while operations continue. Due to the turbine's size, the building facade is open to remove it and install the new Siemens turbine and heat recovery boiler, both delivered via heavy transport. Precision is crucial as the installation space is tight. After cold and hot commissioning, the first phase concludes, paving the way for steam turbine and pipework renewal. Following the incident which damaged the right-hand main landing gear and engine pylon, SOAR initiated the field recovery of the Boeing 757-200. The process began by deploying specialized lifting equipment to stabilize the aircraft. Airbags were carefully positioned under the fuselage to raise it without stressing the damaged components. Once elevated, a temporary gear support was installed. The aircraft was then slowly towed across the airfield using a controlled, low-speed method. Finally, it was relocated to a designated parking position without any further damage during the entire recovery operation. The Boeing 747 is dismantled using a powerful excavator equipped with a demolition tool. First, the machine begins by tearing through the fuselage skin, creating large openings. It then rips off sections of the upper deck, crushing and folding the aluminum panels. The operator proceeds to destroy the cockpit, breaking the windshield and collapsing the frame. Next, the tail section is pulled apart, with the vertical stabilizer and rudder being crushed and separated. The wings are attacked last, with the hydraulic tool cutting through the internal ribs and spars. Throughout the process, the excavator methodically reduces the aircraft into twisted metal pieces, ensuring that large components are disassembled for easier transport or recycling. The entire operation is executed with precision and force. Using two heavy-lift cranes, teams carefully detach the Boeing 747-400's wing sections. The wings are lifted and removed piece by piece, ensuring safe precision and balance. The upper fuselage of the Boeing 747-400 is carefully dismantled using cranes. Sections are detached systematically to ensure safety and control. This step is part of the aircraft handling and dismantling process at the end of its service life. The scrapping of the USAF Boeing KC-135, tail number 563623, at Shepherd Air Force Base was carried out using heavy construction equipment, primarily hydraulic excavators fitted with specialized demolition attachments. The process, which lasted approximately half a day, was carefully executed in stages to ensure efficient breakdown and separation of aircraft components for recycling. The operation began with the deployment of a hydraulic excavator, equipped with a powerful hydraulic cutter and a clamshell-type demolition grab. The initial focus was on removing the aircraft's tail section. The operator precisely maneuvered the hydraulic grab to grip and rip off the vertical and horizontal stabilizers at the rear of the aircraft. The vertical tailplane was bent and torn off, followed by the horizontal tailplanes, which were forcibly removed from the fuselage structure. These components were neatly removed to allow easy access to the rest of the aircraft.
It is. Come forward a little bit more. Keep coming. Keep.
With the tail section completely dismantled and moved aside, the demolition crew shifted their attention to the wing structures. Each of the two massive wings was tackled individually. The excavator grapple was used to grip the junction between the wings and the fuselage. With repeated forceful movements, the wings were detached by tearing through the internal supports and fasteners. As the wings separated from the body, they were dropped to the ground and relocated to a separate area for further processing. Following the wing removal, the excavator began attacking the main fuselage. The operator used the hydraulic grapple to apply pressure to critical points along the aircraft's midsection, causing the fuselage to collapse inward. The process continued until the fuselage was split into two large halves, exposing the aircraft's internal structure, wiring, and frame. This division made it easier for equipment to access and crush the remaining parts.
Danny, push it, bud. Push it.
To support the ongoing work, a second excavator was brought to the site. This machine was tasked with clearing the dismantled parts and repositioning them for further demolition. It relocated components such as wing fragments and tail sections into a consolidated pile. Meanwhile, the first excavator focused on breaking down the front fuselage, including the cockpit and nose area, which contained reinforced structural elements and avionics compartments. Once the aircraft had been separated into its major components, the two excavators worked in tandem to further reduce the sections into smaller, manageable pieces. Each machine alternated between gripping, crushing, and twisting aircraft panels, fuel lines, and structural members. The grapple arms applied continuous force to tear apart aluminum skin panels, stringers, and internal bulkheads, leaving behind piles of shredded metal. Finally, the broken-down fragments were collected and loaded onto trucks. Using the hydraulic grapples, operators carefully picked up smaller pieces of scrap and placed them into waiting transport vehicles. These trucks carried the crushed metal to a shredder for further processing and recycling, completing the disposal cycle. The entire dismantling process showcased a methodical approach to aircraft demolition using standard heavy-duty construction equipment, demonstrating both efficiency and safety. By using hydraulic excavators with multifunctional grapples, the crew was able to systematically dismantle the Boeing KC-135, separating its parts by category and preparing the materials for recycling without the need for manual labor. This process not only reduced the aircraft to recyclable material, but did so in a manner that minimized environmental impact and maximized material recovery. The stripped Boeing 737-200 frame ex-Aloha Airlines is lying in the Mojave Boneyard. At the start, a forklift is brought to lift one wing section. That wing is carefully raised using the forklift, creating lift under the wing spar. On the other side, the opposite wing and fuselage are propped up on stacked wooden blocks, providing support and elevation. The wooden cribbing is assembled into a stable stack beneath the wing root and lower fuselage, raising that side of the airframe. Once the first wing is lifted by the forklift and the frame is balanced, a second forklift is brought in. This second machine replaces the wooden supports by directly lifting the other wing section. Wooden blocks are removed gradually as the forklift takes more of the structural load. At this point, both the forward wing section and the fuselage are fully supported by forklifts, one on each side. With both forklifts engaged, they begin to move in tandem. Slowly, the two machines lift and drag the entire fuselage frame while staying level. The synchronized motion ensures the shell remains flat and stable as it is towed across the yard. The fuselage is then relocated toward a designated dismantling or processing area. The movement appears smooth and methodical, with both forklifts guiding the airframe over the ground, dragging it to the next handling location. Throughout, there is no introduction of cranes or external slings. Only forklifts and wooden cribbing are used. The entire sequence from lifting one wing, supporting the other, engaging two forklifts, to towing the shell is contained within what the video depicts, and no unrelated background detail is included. Bailes. Using a heavy-duty excavator fitted with demolition attachments, the team begins the controlled removal of the 747-400's nose section. First, the excavator is equipped with a hydraulic clamp, gripper bucket. This tool is used to latch onto the cockpit area, the forward fuselage, including windscreen and front structure. In the initial phase, the excavator operator carefully grips and detaches this forward section, pulling it away from the fuselage structure as a single piece. With the cockpit segment shifted off to one side, the excavator proceeds to the next phase, breaking it down into smaller pieces. The hydraulic clamp now tears through internal components, paneling, wiring, cockpit instrumentation, insulation, and structural frames, reducing the section into manageable fragments. Each bite from the gripper shreds material into chunks, sorting lighter debris from heavier metal. The operator rotates and repositions the clamped jaws, applying pressure and squeezing pieces apart. This systematic approach ensures the efficient separation of internal components from the outer shell, while the cockpit structure is segmented into small, recyclable parts. The combination of the hydraulic clamp's strength and precision allows both coarse removal and detailed dismantling. Overall, the process transitions from a macro separation cockpit removal to micro demolition fragmentation of parts, preparing the materials for recycling or disposal in a controlled, methodical sequence. A pair of heavy hydraulic excavators initiate the controlled demolition of the Boeing 747-400. Both are fitted with specialized demolition tools and powerful hydraulic grapples. One excavator focuses on dismantling the central fuselage section, while the second works on the aircraft's tail section. As the operators maneuver the machines, the excavators use their hydraulic buckets to tear through skin, frames, and support structure. The excavator assigned to the mid-body slices and pulls apart the wing roots, cabin shell, and floor beams, gradually reducing the plane's large central section into smaller, manageable fragments. Simultaneously, the tail section excavator fractures the vertical stabilizer, horizontal tailplane, and rear fuselage. Both machines shred and split the metallic structure until the aircraft is essentially ripped into numerous irregular pieces. Through coordinated effort, the excavators break the airplane into transportable debris, separating salvageable components from scrap. The process, driven by hydraulic power, precise control, and continuous tearing action, efficiently transforms the intact aircraft into piles of smaller steel and aluminum fragments, ready for removal and recycling. Econ. The dismantling of the Boeing 767 aircraft, tail number N301AA, marks the end of service for one of American Airlines' historic jets, the first and eighth 767s ever built. The scrapping process begins after the aircraft's landing gear is removed. Without its landing gear, the aircraft rests on wooden railroad ties to keep it elevated temporarily. A heavy-duty hydraulic excavator then pushes the entire fuselage off the wooden supports, lowering the plane onto the ground to create a more stable platform for further demolition. Once the aircraft is grounded, the excavator is repositioned to the rear of the fuselage. Equipped with a powerful shear attachment, it begins the process of cutting off the tail section. The operator carefully slices through structural connections, severing the tail from the rest of the fuselage. This marks the first major separation in the dismantling process. After the tail is removed, the excavator moves toward the forward end of the aircraft. The next step is to cut the forward fuselage away from the mid-center section. With precision control, the shear is used to break apart the aluminum structure along key joints. This creates three large segments: the tail, the center fuselage, and the nose. Meanwhile, demolition crews manually work on removing specific components from the forward fuselage. Using torches and hand tools, they begin detaching the cockpit section and carefully removing the passenger doors. These elements may be preserved for historical, educational, or display purposes. As the crew focuses on the cockpit removal, the excavator continues tearing down the remaining fuselage structure. Large portions of the aircraft skin are ripped open. Internal systems like insulation, electrical wiring, and cabin components are pulled apart. The structure is gradually reduced to manageable pieces, many of which are sorted for recycling, including metals and composite materials. Special attention is given to the aircraft's cockpit due to its historical significance. The cockpit of N301AA is successfully separated and preserved intact. In March 2012, it was placed on public display at the North Las Vegas Airport. This display serves as a tribute to the aircraft's legacy, allowing future generations to connect with a piece of aviation history. Overall, the process combines efficient mechanical demolition with careful manual extraction, reflecting both the industrial nature of aircraft scrapping and the respect given to historically significant parts. The dismantling of N301AA not only recovers materials but also honors the service of one of American Airlines' most iconic jets. A heavy-duty lift vehicle slowly pushes the retired U.S. Air Force T-37 jet trainer toward the designated dismantling area. The aircraft, showing signs of age and decommissioning, rolls forward with slight resistance. The machine carefully guides the jet onto a concrete surface where demolition operations are set to begin. Once the aircraft is properly positioned, the lift vehicle withdraws, and the focus shifts to the hydraulic excavator standing nearby, equipped with a powerful clamshell grapple attachment. The excavator approaches the nose of the T-37 and lowers its grapple onto the forward fuselage. The steel jaws clamp down tightly and begin to tear into the front of the aircraft. With controlled force, the grapple crushes and rips apart the cockpit area. Aluminum panels bend, break, and fall away as glass from the cockpit windows shatters and drops to the ground. The nose section is methodically dismantled into fragments, exposing the internal structure, including the avionics bay and wiring systems. With the front of the aircraft destroyed, the excavator repositions itself to attack the center fuselage. The grapple clamps onto the midsection and applies increasing pressure, deforming the jet's body. The fuselage bends, breaks, and splits apart, with ribs and support frames torn loose from their original alignment. The operator maneuvers the grapple to tear away at internal components, leaving nothing intact. The seats, flooring, and sidewalls are dismantled and dropped into the growing pile of debris. Next, the excavator targets the wings of the aircraft. It first approaches the left wing, positioning the grapple over the root section where the wing joins the fuselage. The jaws close and twist, ripping the wing loose from its mounts. The wing crumples under pressure and detaches in large pieces. The same process is repeated for the right wing, which is similarly torn off and crushed. Both wings are reduced to twisted metal, stripped of their former aerodynamic shape. Piece by piece, the excavator continues to crush and break apart the remaining sections of the jet. The tail assembly, including the horizontal and vertical stabilizers, is also dismantled and rendered into small fragments. No component is spared as the machine ensures that the entire aircraft is dismantled beyond recognition. By the end of the process, the once intact T-37 trainer has been completely demolished. The aircraft is now nothing more than a heap of mangled metal, shattered glass, and scattered wiring. Every major component, the cockpit, fuselage, wings, and tail, has been methodically destroyed by the hydraulic excavator, completing the dismantling process in full. An excavator crane positions its boom over the fuselage crown. The operator secures the massive 15 feet times 20 feet times 35 feet crown skin. With precision, the crane lifts and peels away the section from the top of the Boeing 747 to 400. This remarkable dismantling operation features the precise disassembly of a retired Boeing 777 to 300, executed meticulously using two cranes working in harmony. At the outset, both cranes are positioned on either side of the aircraft, bracing the fuselage with sturdy rigging. The first major move involves lifting the cockpit section. One crane elevates it gently while the other stabilizes the adjacent fuselage, ensuring a controlled separation. Next, the tail assembly is detached similarly, carefully unbolted, secured by slings, then lifted out as a single intact unit. Progressing forward, each cabin module, first the passenger compartment, then the baggage hold, is methodically unfastened from the airframe. The cranes coordinate seamlessly. As one lifts, the other adjusts tension and alignment, maintaining perfect balance. Key structural components such as the wings and engine pylons are then dismounted. The synchronized crane movements ensure safe, damage-free removal of these heavy parts. Finally, the empty fuselage is lifted away, marking the completion of this exceptional multi-stage disassembly, showcasing both precision engineering and expert crane operation. Over a period of 18 days at San Bernardino Airport, Jet Yard carried out a special disassembly of a Boeing 777 airframe. The process involved cutting and separating the fuselage, starting just behind the wings and continuing all the way to the tail. This method had never been attempted on a 777 before. Workers used heavy equipment and precise planning to dismantle the sections without damaging key structural components. The disassembled parts, including large fuselage sections and the tail assembly, were carefully loaded onto trucks. These sections were then transported back to Boeing's facility in Everett, Washington. The goal was to reuse the airframe segments for future manufacturing analysis. Boeing used these parts to study design and assembly improvements, aiming to streamline production methods and increase efficiency in future builds of the aircraft. Two powerful hydraulic excavators, each equipped with giant grapple buckets, methodically dismantle a retired Boeing 747. With precision and care, the machines clamp onto the aircraft's fuselage, tearing through layers of metal with unmatched force. At each step, one excavator focuses on stabilizing a section, while the other targets key structural components, wings, tail, and underbelly panels, ensuring controlled, safe disassembly. Bays. The synchronized movements of these hulking machines resemble a delicate dance. One grips firmly, the other applies vertical or horizontal force as needed, peeling away the aircraft's skin in large sheets. As chunks of aluminum and titanium fall away, internal systems, pipes, wiring, and insulation are exposed and loosened, to be sorted later for recycling and salvage. Throughout the process, dust rises around the gutted frame, while cranes and support crews stand by to collect and transport hefty components, landing gear, engines, and cockpit instruments. This operation transforms a once majestic flying Titan into neatly sorted raw material, ready for repurposing. In the end, the coordinated teamwork between two hydraulic excavators highlights both the elegance and efficiency of modern aircraft recycling. A heavy-duty crane carefully lifts the retired Boeing 707 fuselage off the tractor-trailer. Stabilizing chains secure the frame as workers guide the crane's hook. Slowly, the aircraft fuselage rises into the air, swivels clear of the trailer, and is gently placed onto supporting blocks. With precision and caution, the fuselage is safely transferred for its next purpose.